Welcome back. So today we're talking about inscribed angles. So we're going to start out with a theorem. If an angle is inscribed in a circle, then the measure of the angle equals half the measure of the intercepted arc. So before, when we were talking about central angles, we started at the center and then our sides were radii and they were equal to the arc. Now we're going to pull that back a little bit and our vertex is now on the circle and our sides are chords for that circle. Now it's half of whatever the arc is. Okay, so if we look at our example, we have the measure of angle ABC is half of the measure of arc ADC, or if you want to start by looking at the arc, our arc ADC is twice as large as our angle ABC. Okay, so let's look at an example where we're going to get to use this. So we have our picture here. We have circle O. We have a couple different pieces of information that they give us. They tell us the measure of arc AB is 60, so we're going to mark that as 60. And the measure of arc BC is 100, so we're going to mark this as 100. And then they also tell us that the measure of arc AD equals the measure of arc DB. Okay, so I'm going to start out, instead of finding my angles first, I'm actually going to find all of the arc pieces. So whenever I'm trying to find my arc pieces, I'm going to look at the whole, so it's 360 equals what pieces do I need to add together to get that 360. I need my AB, which is 60, plus my AD and my DB, and I know that those are the same. Okay. And that equals my 360. Okay, so then from there I'm going to subtract my 60 from both sides. I get 300 equals AD plus DB, and remember these are arcs, so we want to make sure we label that. AD and DB are the same thing, so this is actually 2 times AD. So 300 equals 2 times AD, so I'm going to divide by 2. And I get 150 equals arc AD. Okay, so I'm going to go ahead and label that. Now I also know that that's equal to DB. DB goes all the way from here around. This piece is already 100, so this piece is going to be 150 minus 100, which is 50. Okay, so that's actually 50 degrees. So now we have all of our pieces. Now we can start looking at our angles. So the first one I'm going to look at, angle 1. So this is an inscribed angle. The arc that it intercepts is this large arc AD. So the measure for angle 1 equals half of arc AD. AD is 150. So half of that would be 75. Okay? So then for the next one I'm going to look at is number 2. So for this one I have an inscribed angle again. Now I'm looking at the arc goes from D to C, so that's this one. Again, my angle is going to be half. So the measure of angle 2 equals half of DC, and we know DC is 50, so it's half of that, which is 25. So the measure of angle 2 is 25 degrees. Now we're going to look at angle 3. So looking at angle 3, the arc is from B to C, which is my 100. So the measure of angle 3 equals 1/2 of BC. BC is 100, so half of that is 50. So the measure of angle 3 is 50 degrees. So then for number 4, again we're going to be looking at the arc it intercepts. So the measure of angle 4 is 1/2 of AB, and we have AB is 60, so it's half of 60, which is 30. So the measure of angle 4 equals 30. And then the last one is 5. 5 intercepts BC again. So if we look over here for BC, so we know this is the same for 5. So the measure of angle 3 equals the measure of angle 5, which equals 50 degrees. Okay? Alright, so let's move on. So we have a few more theorems here. So theorem 10.6 says that if two inscribed angles of a circle intercept congruent arcs, or the same arc, then the angles are congruent. Okay, so that's similar to what we just did over here on this piece. So we had angle 3 and angle 5. They both intercept this arc, BC, and so they were congruent. That's why those were congruent. Alright, moving on to the next one. 10.7 says if an inscribed angle intercepts a semicircle, the angle is a right angle, which makes sense because if it intercepts a semicircle, that's 180 degrees, and we said that it's half, which would be our 90. Okay, so we have another example here that we're going to work on. This does happen to have some diameters in it, so we can work with that semicircle piece. So we have our circle here. We have A, B, D, E, and our center is F, and then we have angles 1, 2, 3, and 4. So triangle ABD and ADE are inscribed in circle F, with AB and BD being congruent. Okay, so this arc AB is congruent to arc BD. Okay? Alright, so then it says find the measure of the numbered angles if the measure of angle 1 is 12x minus 8 and angle 2 is 3x plus 8. Okay, so let's look at those. So angle 1, we're intercepting ED, and angle 2, we're intercepting AE. So if you notice, those are the two pieces on this side of our diameter, so those have to add up to 180. Okay, so we're just going to add those two expressions together. So we have 12x minus 8 plus our 3x plus 8. Remember, those should add up to an arc of 180, so my angle should add up to 90. Okay? So remember, the arc is 180, but my angles are inscribed angles, so they're going to be half of that, which is 90. So 12x and 3x, I have 15x. Negative 8 plus 8, those cross each other out, so 15x equals 90. So dividing by 15, so that would be 6. So x equals 6. So then if I plug those back in, so the measure for angle 1 is 12 times 6 minus 8. 12 times 6, we get 72 minus 8. So then we have 64. And then for the measure of angle 2, we're going to have 3 times 6 plus 8. 3 times 6, we're looking at 18 plus 8. So we're looking at 26. Okay, if we add these two together, we should get our 90. 60, 70, 80, and another 10 is 90. Okay, so I have the measure of angle 1 is 64. The measure of angle 2 is 26. Okay. Alright, so then for this last piece, for angles 3 and 4, it says that these chords, the arcs are congruent, so that means our chords also have to be congruent. And so that would mean that our angles are going to have to be congruent as well. So if we already know that B is a right angle because it's intercepting a semicircle, so that means it has to be 90, the two angles 3 and 4 have to be 90 as well, and if they're equal, that means they're 45. So the measure of angle 3 equals the measure of angle 4, and the measure of angle 3 plus the measure of angle 4 equals 90. So these equal 45 degrees. Okay? So again, the reason why 3 and 4 are congruent is because these arcs that they intercept are congruent. So the angles must also be congruent. Okay, and we knew this was a right triangle because this intercepts the semicircle, so that's 90 degrees. So we only have 90 left, so they have to be 45. Okay? Alright, let's keep going. So the next piece that we have here, we have a quadrilateral ABCD that's inscribed into circle P. If the measure of angle B is 80, so I'm going to go ahead and label that, and the measure of angle C is 40, we're supposed to find A and D. Okay, so let's look at this. So if B is 80, what does that tell us? That tells us that from A to C, that arc is 160 because the angle is half. If we know that C is 40, that tells us from D to B is 80 because the angle is half. Okay? So then how can we find the measures of A and D? Well, a couple different things that we have going on here. Number one, D is intercepting arc A to C. So from A around the backside is 160, we're going the other direction. So ADC equals 160, okay, and ADC plus ABC equals 360. That's the whole way around. We've got one going this way, we've got one going this way. So I have 160 plus something equals 360. So I'm going to subtract my 160. So I get A, B, C equals 200. So if A, B, C is 200, then this angle D is half of that. Angle D equals half of ABC. So angle D equals 100. So this is 100 degrees. Okay? Alright, now let's look at A. So we said this angle, this arc BAD equals 80, and DCB is the one that A intercepts. If we add those two together, just like we did over here, we get 360. So we're going to take DCB plus 80 equals 360. So subtracting our 80 from both sides, we get DCB equals 280. So then the measure of angle A equals half of DCB. So the measure of angle A is half of 280 degrees. Oh, I apologize. Can't see that. So I was just writing the measure of angle A is half of arc DCB, which goes this way. That's the arc it intercepts. It's half of that, and we know that arc is 280 degrees. So then the measure of angle A equals 140 degrees. Okay? Alright, so then one last theorem here that we just saw. If a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. So let's go up here and look at these. So we have a quadrilateral. Our opposite angles, we have 40 and 140. That comes out to 180. That is supplementary. And my other opposite angles, I have a 100 and an 80. Again, if I add those together, they are supplementary. So that does work. Okay, so again, that last theorem, if a quadrilateral is inscribed in a circle, then its opposite angles are supplementary. Okay, that's all I have for today. I'll see you in class tomorrow.